Next, we have tubals. Nice. Now, tubals, let's see an example of tubals. I have already explained what it is. So we have tubals, some point as a constant. We have 1 and 1. 1 in the first value and 1 in the second value. So switch, it will check the value of some point and enter the cases. So the first case, the 0 in the first value and 0 in the second value must equals to 0. So here it equals to 1 and the second value is equal to 1, so it will pass. It won't print this, so it will move to the next one. So it will check for underscore for the first value and 0 in the second value. And here the underscore, it means to match any possible value, and it means, or also known as wildcard pattern. So here I don't care what is the first value, I care about the second value, and it must equal to 0, and which is not true, so it will move to the next one. And it's similar to here, I care only about the first value and it must equal to 0, and the second value I don't care, I only care about the first value and it must equal to 0, and which is false, so it will move to the next one. And the last one, the first value must be in between -2 and 2, the second value must be in between -2 and 2, which is true. If we run that, and we will say, we will get 1 and 1 is inside the box, which is this one, which is true. Okay, that's the example of using switch with tubals. Let's mark this as complete and move to the next one. Value bindings. Interesting. The value binding is similar to tubals, where we used a wildcard underscore. So let's take this as an example. For example, we have a constant, another point, which has 2 as a first value and 0 in the second value. Switch will check the value of another point. So it will check for the first case, let x, and let x is value binding. Okay, I don't mean to check the value for the first one. However, it must have 0 in the second one. Okay, the same goes to other case. I care about the first value, which must contains 0, and I need to have the other value as a constant, temporary constant. Okay, so in this example we will get the first one on the x-axis with an x value of, it will give you the x value which is true, with this, which is 2, sorry, and we will get yes on the x-axis with the nx value of 2. Okay, however, if we say, okay, let's say 1. Okay, if we change it to 1, this one, it will pass. The second one, it will pass, because the second value is equals to 1, the first value is equal to 2, and we will get somewhere else at 2 and 1. Let's run and see. Somewhere between somewhere else at 2 and 1. Very simple, right? I know. Next we have where. Cool. So where, a switch case can use a where clause to check for additional conditions. Let's see, for example, as in here, okay? Or you know what, in here, okay? let's say where x equals to y. Okay, so in here, and it gave me an error. Let me explain. So if x and y, okay, I have the value in temporarily constant, okay, I want to make this case true where x equals to y. The value of x equals to y. If the value of x is 2 and the value is y is 2, this one will be true. Otherwise, I should say we should have a default value print nope, okay, because it failed. Let's run and see. So it's no. Okay, fine. Let's change that to 2 and run again, and we should say we should get somewhere else at 2 and 2. So we can use where when we have an additional condition. Very simple and very easy. Now, what else we have? We have compound cases. Very cool. So compound cases, multiple switch cases that share the same body can be combined by writing several pattern after case. For example, let's say this one is true, right? Okay. Let's have another case. Okay, let's move that to this. Okay. So let's say case 1 and 2. Okay. Or 2 and 1. Let's give that a space. Or 3 and 1. Okay. So compound cases is when we have, for example, let's say print compound. Okay. Okay. Let's run again. And we will still get, yes, okay, compound. Okay. Because x and y, it's not equal to each other. They are not equal. So it will move to another case where either the value of another point is 1 and 2, or 2 and 1, or 3 and 1. Okay? So in this way, you can say, okay, for example, another case. Okay, let's say and x. Okay, we will still get yes. If we run down here, okay, we will still get yes, because the comma doesn't mean and, it means or. Okay, and it's similar to here. If we say case 0 1, sorry, 0 1 2 3 4 5 and so on, it's all the same. Okay, however, it's up to you. Now what's next? We have the control transfer statements. Fine. My god, control transfer statements change the order in which your code is executed by transferring control from one piece of code to another. Swift has 5 control transfer statements. We have continue, break, fall through, return, and through. So, for example, we have let's mark that as complete, and let's check for continue. So the continue statement tells a loop to stop what it's doing and start again at the beginning of the next iteration through the loop. It says, I'm done with the current loop iteration without leaving the loop altogether. Let's see an example. Let's have this as an example. We have puzzle input, puzzle output, and characters to remove. All right. So for example, we have puzzle input, and we are getting the character from the array. All right, because puzzle input is a string, and if you put it inside a loop, for loop, it will convert it as characters. Okay, and inside the for loop, we are checking is characters, okay, that are the vowels, okay, are available. Okay, for example, the character G, okay, it will first check G as a character. If it is contained, if characters to remove, if the array, if this array, let me explain what's going on. So puzzle input is a string, okay? If you put it inside a for loop, you will get characters. For each character, you will do whatever you want. So in here, we have array, okay? And we are checking the character. If array contains character, continue. Otherwise, append. Okay? So the character G, is G available in this array or not? If it does, continue. And let's see the result. So we will get G, R, T, E and A removed. The space is removed. So in this example, if it is available inside this array, if the character is available inside this array, it should not added to that string. So G is not available, R is not available, so it will be G, R. E is available, so it will be ignored. A is available, so it will be ignored. T, it will be added as in here, and so on. Okay? However, if we use break, okay, and run again, we will get GRTGR, and done. So the break statement ends execution of entire control flow statement immediately. The break statement can be used inside a switch or loop statement when you want to terminate the execution. So